Welcome to CE 402 Environmental Engineering 2 Module 6 Part 2. In this session I am going to discuss about the sledge thickening methods. What is a sledge thickening method? This method is used for densify the sledges collected from the primary sedimentation tank and secondary sedimentation tank, and this will help while dewatering the sledge and to dispose of the sledge collected from the wastewater treatment system. And there are several methods adopted for these sledge thickening methods, and this will enhance the volume reduction, and it will increase the sludge concentration, and it will accelerate the process of thickening, that is the densification of the solids in the collected sludge. Then what is the purpose of sludge thickening? It is to permit increased loading to sludge digesters and to increase feed solids concentration to vacuum filters and to economize on transport cost as an ocean barging in case of raw sludges, and to minimize the land requirements as well as handling cost when digested sludge has to be transported to disposal sites, to save on the auxiliary fuel that may otherwise be needed when digested when incineration of sludge is practiced. Then there are three types of sludge thickening methods, that is gravity thickening, air flotation and centrifugation. First one is gravity thickening. This is the most commonly practiced concentrating methods of sludge thickening, and this is least expensive and simplest method. And in this method, you can see that the sludge is fed into a container, that is just like a secondary sedimentation tank. This is you can see the influent coming from one side, and the supernatant liquid will be collected from the effluent side, and a scraper is provided at the bottom of the tank to scrap off these thickened sludges. And these are two types, that is continuous flow type and fill and draw type. And you can collect the sludge from the bottom of the tank. Through the scraper arrangement, all the settled sludges from the bottom of the tank can be collected, and this will be transported to further treatment. This is the gravity thickening method. And this resembles a circular clarifier, that is secondary clarifier, and the sludge loaded here is the diluted sludge, that is the sludge in the form of liquid. And here you can see the continuous supernatant flow that results from this gravity thickener is returned to the primary sedimentation tank or primary clarifier. And the continuous flow tanks are designed for the hydraulic loading likely to give rise to odor problems. And the normal sludges contain too much with the planned effluent. The recommended solid loading for primary and activated sludge, that is 60 to 40 weight ratio, are 100, 60 and 40 kilogram per day per meter square respectively. And the underflow solid concentration that can be expected with these loadings are about 8 to 10% with the primary, and 6 to 8% with the primary and trickling filter, and 2 to 6% with the primary and activated sludge. Better efficiency can be obtained by providing slow revolving stirrers, particularly in gassy sludges. That is, these gassy sludges will bring these solid particles from the bottom side of the thickening tank to the top of the tank, and it will mix up with the supernatant and in the tank itself, and it will come with the effluent that is not admittable. And you can see the clear supernatant on the top, and there is a feed zone that is by hindered settling, and you can see the compression zone where the solid concentration is very high. In operation, a sludge blanket is maintained on the bottom of the thickener to aid the concentrating of the sludges. The concentration of underflow solids is governed by the depth of the sludge blanket up to 1 meter, beyond which there is very little influence of the blanket. And the detention time is 24 hours for maximum compaction, and the sludge blanket depth may vary with the fluctuations in solid production and achieve good compaction. And the next is flotation thickening. In this flotation thickening, you can see this is a flotation thickener. Here the influent is get into the tank from the bottom side of the tank, and the effluent is collected from the top side of the tank, and here is a pressure arrangement connected to the tank system, that you can see a pressure reducer is given, and a pressurizing pump was also connected. Here you can see the effluent coming from this tank is recirculated into the same tank, that is the flotation tank, and while recirculation the effluent is pressurized using pressure pumps, and air dissolution happens, and there is a pressure reducer arrangement. It is mixed with the influent, and due to the pressure difference, and it will release to the atmospheric pressure, then it will bring the particles, that is the solid particles, to the top of this flotation tank, and there the sludge blanket will be formed, and this sludge blanket is removed by the float collector, that is a rotating conveyor belt, and the sludge blanket is collected through that, and the supernatant will be collected through the effluent part, and it is recirculated into the tank itself. The recirculation is will depend upon the quality of the effluent coming out. Depending upon the quality, the recirculation will be 30 to 150% of the influent. And next is the centrifugal thickening. Centrifugal thickening, as the name suggests, it is thickened due to the action of the centrifugation. That is, the both purposes are satisfied during this process. That is the centrifugal thickening, that is dewatering and thickening process. And here you can see the influent is fed into the centrifugation chamber, and due to the centrifugal activities, the solids are collected on the surface of the centrifugal arrangement, and these solids will be collected from there, and the supernatant will be separated, that is the water will be separated from this, and it will be collected through the outlet arrangement. You can see the sludge cake discharge here, that is at the end of the centrifugal arrangement, and the here the water collection, you can water can be collected from this arrangement also, and a total cover of this arrangement will be given, and you can see the feed pipes here, and the rotating bowl is also shown in figure, and a rotating conveyor and scroll belt you can see, which will help to transfer the solids from one end to another end, and one end to the last collection point end. That is, and a gear reducer is also given in order to change the pressure, and here you can see the dewatering breech. I hope you understood the topic about the sludge thickening. Thank you for listening. See you in the next class.